Find where the tangent to the curve y is equal to 50 divided by the square root of x squared plus 16 at the point x equal to 3 meets both axes. Now, to improve your success with this question, maybe you should try to draw this graph, and maybe the line x is equal to 3, and if your software allows you to actually put the tangent on. So this is one I drew in GeoGebra. So here we have the original graph, y is equal to 50 over x squared plus 16. Here we have the line x is equal to 3. This is the point where they intersect, and the red line here represents the tangent, which I've got to find, and I'm being asked to find the coordinates of B and A. So, writing down that y is equal to 50 over x squared plus 16. So how do we find the equation of the tangent, which is what we're going to do? We will need to differentiate it at this particular point here. So trying to differentiate it. So first of all, writing down that we've got 50 x squared plus 16 to the minus a half, using these rules of indices. A to the minus 1 is 1 over a to the n. So we're sort of using them backwards. And that the square root of a is a to the half. So combining those two. And now we can differentiate using the chain rule. So using the chain rule, we can say that dy by dx, so using the chain rule, you take the minus a half, you multiply by 50x squared plus 16, reduce the power by 1, so minus a half take away 1 is minus 3 over 2, and then you have to remember to differentiate the bracket, so that differentiating the bracket only gives you 2x. So the 2 and the 2's here will now cancel, and we're going to be left with minus 50x x squared plus 16 to the minus 3 over 2. It might be better if you write it as minus 50x over x squared plus 16 to the 3 over 2 using this rule of indices. Right, now we've got that dy is equal to that. We need to find the coordinates of this point here where they intersect. So at x is equal to 3, this is where this line is. Dy by dx will be minus 50 times 3, so this is going to actually find the gradient of the tangent, over 3 squared plus 16 to the 3 over 2. So using your GDC or your calculator, make sure you use the fraction button, and don't forget the minus sign up front. You're going to get the gradient is minus 6 over 5. Finding the y coordinate of P, or this point here, we need to put it in, substitute it into y. So we're going to get that y is 50 over the square root of 3 squared plus 16, which is equal to 10. So again, doing that on your GDC using the fraction button. So in order to find the equation of the tangent, we can use either y is equal to mx plus c, but I prefer to use y minus y1 is equal to mtx minus x1. So this is x1, this is going to be mt, and this is going to be y1. So we're going to have y minus 10 is equal to minus 6 over 5 x minus 3. Right, so dividing, because it's dividing by 5, it's a good idea to take the 5 up here. So 5 brackets y minus 10. Spanning here, we've got minus 6x. And then minus 6 times minus 3 is plus 18. Don't forget, that's a plus sign. Spanning the bracket here, we're going to get 5y minus 50 is equal to minus 6x plus 18. Taking 6x over here, we get 6x plus 5y. And then minus 15 minus 18, it will be minus 68 is equal to 0. So we've now found the equation of the tangent. We can now find where it cuts the axis. So on the x-axis, y is equal to 0. So if we put y is equal to 0 in this, we're going to have 6x plus 5 times 0 minus 68 is equal to 0. 6x is equal to 68. X is going to be 34 over 3. When you put this on your calculator, it will cancel it down for you. For the y-axis, x is equal to 0. So we'll put x equal to 0 in this. So we're going to have 6 times 0 plus 5y minus 68 is equal to 0, which gives 5y is equal to 68. Y is equal to 68 over 5. And then writing all out, the tangent meets the axis at 34, 0, x 0, and 0, 68 over 5. So this point here is 34 over 3, 0. This point here is 0, 68 over 5. Okay, so this has been a video to show you how to find the equation of the tangent, and then at a particular point, x, and then once you've done that, being able to find where the tangent cuts the axis. I hope you've understood, and I thank you very much for watching.